Hello, good afternoon. My name is Dennis van Doorn. I'm from Fujitsu Components Europe. We are a manufacturer in a lot of hardware components, but mainly focusing right now on the wireless stuff. It's not very good visible, I believe, but what I want to introduce to you guys is the Fujitsu IoT connectivity solution. Fujitsu IoT connectivity solution is bringing together building blocks to offer a complete or almost complete solution to our customers in the IoT. The major building blocks are from ourselves, are the hardware part. We are a hardware manufacturing company, as I already mentioned. We are making Bluetooth modules and also extending that to devices which contain this Bluetooth module, these modules. To offer solutions, IoT solutions to the market, we discovered that there is a need to cooperate, to co-create our solutions together with partners. That's why we partnered up with some very interesting software companies doing all range of solutions that are an addition to our devices. And one of our key partners in this is the company Wirepas. And that's why I would like to introduce Richard Kinder. And he is going to explain you a much more detailed than I can view on the mesh technology that Wirepas has developed. So Richard, the stage is all yours.
Thank you very much. So my name is Richard Kinder. I'm responsible for product marketing at Wirepas. What I wanted to do today was to explain a little bit about how we view the connectivity market for industrial IoT applications and compare and contrast some different approaches. So historically, we had a choice between kind of LP-WAN technologies, which are star topology with long-range networks. They may be working in licensed or unlicensed spectrum. So in licensed spectrum, we have solutions such as NB-IoT, Cat-M1 coming from the mobile network operators. And then in unlicensed spectrum, we have solutions such as Sigfox, LoRaWAN coming and being utilized. On the other side of the coin, we also have first-generation mesh networking technologies. And the goal of a mesh is really to build coverage in an area as the number of devices in that area increases. So you kind of get the infrastructure for free. With LP-WAN-based solutions, you're having to install base stations or you're having to pay network operators to provide that connectivity for you. Now that all sounds great from a mesh perspective, but there are challenges in terms of implementing this easily, at scale, in industrial-grade reliability solutions. So what we've been working on actually for a considerable amount of time, really starting with a clean sheet of paper at university, at Tampere University of Technology in 2000, is a radically different approach to mesh networking. Starting with a clean sheet of paper allows you to make the right design decisions and the right design trade-offs to enable massive scale mesh networking solutions. Clearly, the objective here is to enable connectivity in a wide variety of different use cases and settings. That might be wireless sensor networks for predictive maintenance in Industry 4.0 applications or chemical plants. It might be in lighting control systems where you need very low latency operation. Or it may even be in smart utility, smart energy kind of applications where metering data needs to be gotten from a premise back to the head-end system so that we can generate a bill for the electricity that's being used. So when you start with a clean sheet of paper, what it means is that you can design the right philosophy into the product. One of the key kind of design principles that we have is that the system is entirely homogeneous. So each node in the mesh network is deciding for itself how to locally optimize the way that it uses the spectrum energy available to it. With traditional kind of mesh networking approaches, you need to kind of plan the network. You need to decide where you put a routing node, where you put a gateway, where you put an end node or a leader node. And that means that the deployment and rollout is not as easy as it could be. And if you think of a large chemical plant or a large warehouse where you may be deploying tens of thousands or hundreds of thousands of sensor devices, when you have to do network planning around the mesh network, then it becomes very time-consuming to do that. And also, from an installation perspective, the guys doing the installation need to think about which devices go where. So in our opinion, the right way of approaching this is to put the intelligence into the network. What we've been able to take advantage of is the fact that at the very edge of the network, in radio transceiver devices, there's more and more intelligence. So if you look at a chip from Nordic Semiconductor or Silicon Labs, two of our semiconductor partners, then we have as many DMIPs per megahertz in those devices today as the original iPhone had 10 years ago or 11 years ago. So just imagine what you can do with that from an intelligence perspective when you're just running the protocol stack, none of the UI and all of that stuff. So we can harness that power to make very intelligent local decisions about how to route in the network, how to use the radio medium through the media access control there, and push that intelligence and decision making right to the edge of the network. That enables very scalable solutions. It enables very robust solutions as well, because we can locally optimize the channel in use, output power, time slots that we're using, etc. in the network. So it really allows the most efficient use of that unlicensed spectrum as possible. And let's face it, you know, the radio waves are getting more and more crowded. So you need to be very intelligent in how you use that scarce resource until such time as the spectrum allocation policies are redesigned to be a bit more sensible. That's a slightly philosophical topic, which I won't dwell on right now. But essentially what we provide is the ability to get data from sensors to the cloud, commands coming down from the cloud to edge devices and end devices, software updates as well, and then also direct node-to-node communication. And that direct node-to-node communication is very important for applications such as lighting control, where I want to be able to actuate a light from a switch. But also what we're seeing increasingly is a desire to do kind of sensor fusion at the edge of the network. So I can, from a predictive maintenance perspective, I might have one sensor that's measuring vibration on a rotating equipment. I might have another device that's measuring air quality. Well, what if I can actually directly connect those devices together at the edge and use some of that compute power that I talked about to good effect without having to send everything back to the cloud, which introduces latency and introduces, you know, traffic up and down on the network. So to achieve this, what we implement is effectively a Wirepas mesh stack, which is a transport, routing, and MAC layer where all of the intelligence is running in these smart nodes. It runs on standard radio hardware from partners I just mentioned, and it's also frequency band agnostic. So we can run in the global 2.4 gigahertz spectrum, which is great for applications where you need 10 to 100 meters of range. But we can also run in the unlicensed sub-gigahertz spectrum as well. There we have applications such as smart metering, where we're connecting smart meters into an RF mesh. That's particularly popular in Nordic, but also increasingly in India and other markets. The point here is that the intelligence in terms of the routing and the MAC layer is independent from the frequency band in use. So as more spectrum becomes available to IoT applications in the future, then we can take advantage of that spectrum, and so can our customers and partners. So what does this kind of mean in practice? Well, when we start to decentralize or push the intelligence and the decision making down to the very edge of the network, as I mentioned, we can make local decisions regarding what's the RF environment in a particular area that the network's deployed in. This results in the ability, for example, on a link-by-link basis to vary the output power. That sounds quite esoteric. What's the value of that? Well, the value is that it reduces interference for other systems, but it also reduces intra-system interference as well. If you think of a metering room, for example, in the basement of an apartment block, I want to connect those 30, 40 meters using the minimum amount of power, output power possible. And then one of those meters wants to connect to a device a long way away. I want to give more output power. So I can vary that on a link-by-link basis. There's no central controller deciding to do that. It's the network deciding for itself. Another good example is with the routing. So one of the challenges to scaling mesh networks is either you flood the network with packets, which reduces throughput and reduces the overall throughput and capability of the mesh, or you have some kind of routing table. Now, the challenge with a routing table is that it limits your scalability because you need to store that routing table in every node in the network and in RAM. So if you look at alternative approaches, then the scalability of the network is essentially limited by the amount of RAM in each end node because you need to hold a routing table. What we do is very novel in the fact that we have a cost-based routing on the uplink. So each node knows the cost to route to its next parent, so on and so forth up the network. So that gives the best of both worlds. It gives very good performance and very good throughput, but it doesn't inhibit scalability. And the largest single mesh network that we've deployed to date, or one of our customers has deployed to date, is around 750,000 smart meters in a single mesh network in Oslo with Havsland, the utility. So as a design principle, pushing the decision making to the edge of the network gives brilliant advantages in terms of interference tolerance, robustness, reliability, performance, and really we feel is the right way of building mesh topologies. What does this mean in practice? So just get some use cases going here. So one thing I wanted to mention while Dennis is doing this is the fact that
Technology. Yeah.
not everybody is an RF expert, right? So what we're beginning to do and announcing here at Embedded World is a series of reference architectures that takes the Wirepas mesh, Linux gateway software, other assets, and combines that into an end-to-end solution that customers can deploy easily on great hardware from partners like Fujitsu. So how are some customers using Wirepas mesh with Fujitsu as a solution provider?
Well, thank you. Yeah, what is Fujitsu doing is bringing together the building blocks on their hardware, on our hardware, and some of the applications that we are currently rolling out at customers is, for instance, asset management. Let's see if the movie. No, it's not running. This is a movie. So we are we have the possibility with the mesh technology from Wirepas to build a network of anchor nodes in an environment, for instance, a warehouse, and let assets determine their position based on the RSSI information from those anchor nodes. And we can do asset management in a very easy way to deploy into that area, into that warehouse. Some other examples that we are working on and that we are having experience in now is Industry 4.0. I think Richard already explained it very clearly, connecting sensors to each other in a network. Asset management I already briefly touched, but it even comes to a smart building, smart city environment. Imagining that you have, for instance, a lighting installation already running on Wirepas, then you have the base network for all the other devices in a smart building or even a smart city, connecting sensors to that network, using asset management in that same building. This kind of possibilities are there, and this is what we are rolling out with the IoT connectivity solutions.
Mhm.
So I think, yeah, this is what we wanted to show, what we wanted to share with you guys. It's a very interesting technology. I'm very happy with this co-creation partnership. And yeah, thank you very much for your time.
Yeah.